Chapter 8.2, Modeling and Solving Linear Systems. In order to model problems in math, we need the ability to translate words or phrases into the language of mathematics. There are many phrases that can be used to describe many operations. Translating phrases. Addition. Think of some words or phrases that mean addition. First one you might think of is plus. Also, sum. Another one would be together. Added to. Or add or added. Total. Combined is another one. Both, if you're talking about two numbers, and etc. I'm sure there's many more. You might be able to come up with a few. Some words and phrases for subtraction. We have minus, difference, take away, fewer than, less than, decreased by, and many more. Some terms and phrases for multiplication. Product, times, double, triple, etc. And some terms and phrases for division, quotient. The quotient is the answer to a division problem, just like the product is the answer to a multiplication problem. Per is one that is frequently used in word problems. An example might be kilometers per hour. That means kilometers divided by hours. Into. How many times does 5 go into 20? That's really asking what is 20 divided by 5. Ratio or ratio of. Cut into, so cut into quarters, cut into 4 pieces, cut into 2 pieces, etc. Share equally. So if we're going to share something equally between 3 people, means we're dividing it by 3. Split. Half. Quarter. Etc. So some of them are more specific. Half means divide by 2. Quarter means divide by 4. Double is multiply by 2. Triple means multiply by 3. And there are definitely many more ways to describe these mathematical operations using words. When it comes to subtraction, we have to be careful because subtraction is not commutative, meaning that the order of subtraction is important. You have to really think about the phrasing of the statement to determine which order to subtract in. So example, 3 less than a number means start with the number, in this case x, and subtract 3. 3 decreased by a number means start with the 3 and take away the number, so 3 minus x. Write an equation in two variables for the following statements. The sum of two numbers is 15. The first thing we need to do is define our two variables. They represent our two numbers, so we can call them x and y, or any two variables. And then we define our variables. In this case, we can define them in one. We can say x and y are two numbers. We don't know what the numbers are, but we know they're two numbers. Then we need to write an equation that includes x and y to represent this statement. The sum of two numbers is 15. Sum is addition, and is, in statements like this, is often translates to equals for a mathematical statement. The sum of two numbers is 15. The sum of two numbers equals 15. Our two numbers are x and y, so our equation would be x plus y equals 15. A number exceeds another by 5. So we have a number which is going to be represented with a variable because we don't know what that number is. So we could say this is x, and then exceeds another by 5. That means another number. So another number is y. So again, x and y are two numbers. Then we want to write an equation with x and y to represent this statement. A number exceeds another by 5. So x exceeds y by 5. What does exceed mean? It would mean is more than. So x is more than y by 5. That means x is bigger than y, and it's bigger than y by 5. So if we wanted to write an equation, we could write x is equal to y plus 5. Since x is 5 more than y, then we would have to add 5 to y to make it equal to x. Or another way we could write that, if we wanted to write it in terms of y, we could subtract 5 from x. X minus 5 would then equal y. Since x is 5 more than y, if we take 5 away from x, it would be the same value as y. The width of a rectangle is 3 meters less than the length. Our variables, we have the width. We don't know what the width equals, but that's going to be one of our variables. So w equals the width. Then we have the length. L equals length. I always like to draw a picture if I can. So I'll draw a rectangle. I have length and width. It says the width of the rectangle is 3 meters less than the length. So which one is bigger? The length would be bigger. So width equals, the width is 3 meters less than the length. So we start with length and we take away 3 to get the width. W equals L minus 3. Or if we wanted to write this in terms of L, we could add 3 to both sides, and then we get L equals W plus 3. If the width is 3 less than the length, then W plus 3 would equal the length. Daniel is 13 years older than Bobby. We don't know their ages, so that would be our variable. D for Daniel's age. And B for Bobby's age. Daniel is 13 years older than Bobby, so Daniel is the older one. Then if we wrote an equation that was D equals, if Daniel's 13 years older than Bobby, then Bobby's age plus 13 equals Daniel's age. Or in terms of Bobby's age, if we take Daniel's age and subtract 13, since Daniel's 13 years older than Bobby, then we get Bobby's age. One number decreased by 1/2 of another number equals 7. So again, we just have two numbers in this case, one number and another number. We can call one x and one y. So x and y are two numbers. One number decreased. What does decreased mean? That would be subtraction. One number decreased by 1/2 of another number equals 7. So we know it's going to equal 7. Our first number is x, and it is decreased by 1/2 of y. So x minus 1/2 of y is 1/2 times y, or y divided by 2. So that, or x minus y divided by 2 equals 7. So this is one number, x, decreased by 1/2 of another number, y, so y divided by 2, or 1/2 times y, equals 7. Last one, a collection of dimes and nickels has a value of $1.95. What we don't know is how many dimes and how many nickels we have. So D equals number of dimes. I can't just say D equals dimes, because what is it about the dimes? Is it the value of them, the number of them, the color of them, the taste of them? What about the dimes? So we have to specifically say the number of dimes, and N equals the number of nickels. A collection of dimes and nickels has a value of $1.95. What is the value of a dime? A dime is 10 cents. Written in dollar form, that would be 0.10. If we multiply that by the number of dimes that we have, D, that would give us the total value of the dimes. Then if we add the total value of nickels, nickels are 5 cents. In dollar form, that is 0.05. Multiply that by the number of nickels we have. That's going to give us the total value of all the coins, which is $1.95. Creating a system of equations, solving graphically. Step 1, define your variables. Be specific, as I said in the previous page. Step 2, come up with an equation using both variables. Group like terms together. Example, number of adult tickets plus number of children tickets equals total number of tickets, or total value of quarters plus total value of dimes equals total amount of money, or number of loonies plus number of toonies equals total number of coins, or Joe's base salary plus Joe's commission equals Joe's total pay. Step 3, change both equations into y equals. The variable may be different, but both equations should have the same variable isolated. Step 4, solve for the intersection point using your calculator. Step 5, answer the question if it's a word problem with a statement. Example, a movie theater charges $11 for an adult ticket and $8 for children's tickets. There were 240 people at the early movie, and ticket sales totaled $2,370. The box office manager wants to know how many adults attended the early movie. Write a system of linear equations to help the manager determine the answer. Define your variables. Usually, when you're defining your variables, you can get that information from the thing you're trying to find. So we are trying to find how many adults attended the early movie. So number of adults, or in this case, number of adult tickets. So A equals number of adult tickets, or number of adults would work as well. And then we also have, there were adults and there were children. So C equals number of children, or number of children's tickets. B, write down two equations using the info given. So we know a movie theater charges $11 for an adult ticket and $8 for children's tickets. So we know the price of each type of ticket. There were 240 people at the early movie, and ticket sales totaled $2,370. So thinking about our variables, how can we write an equation with our variables and the number 240? There were 240 people at the early movie. Well, remember that our variables are the number of tickets for adults and the number of tickets for children. If we add those together, we would get the total number of tickets. So A plus C equals the total number of tickets sold, or the total number of people who saw the movie, which is 240. That's one of our equations. The second equation, we haven't used the total sales, is 2,370. Can we use that? How would we figure out the sales if our variables are the number of tickets of each kind and we are given the cost of each type of ticket? Well, the total amount of money made, 2,370, would be the cost of adult tickets, which is $11, times the number of adult tickets sold, plus the cost of children's tickets, which is $8, times the number of children's tickets sold, which is C, is going to equal the total sales, which is $2,370. There's our two equations. Part C, change your equations to isolate a variable and solve using your calculator. You can isolate either variable in this case because they're not x and y, so it doesn't matter. Just pick one to isolate, but you have to isolate the same one in each of the equations. So if you pick A to isolate, you're isolating A in both equations. If you pick C, you're isolating C in both equations. I'm going to isolate A, starting with the first equation. A plus C equals 240. I want to move the C away from A, so I'm going to subtract C from both sides. c minus c is 0. I get a equals 240 minus c. Second equation, 11a plus 8c equals 2370. I want to subtract 8c from both sides to move it away from the a. 8c minus 8c is 0. I get 11a equals 2370 minus 8c. I want 1a, not 11a, so I have to divide all of the terms by 11. (11 divided by 11 is 1. I get a equals, I'm not even going to worry about simplifying for these questions. Even if I could, I don't think I can simplify these, but I'm not going to worry about simplifying fractions. Just going to leave them as they are because we're just putting it into our graphing calculator anyways. So we're going to graph both of our equations. We have equation 1 and equation 2. Graph them in your graphing calculator. Go to y equals or menu graph. Get rid of your old equations. Type in your new ones. 240 minus, your variable is always going to be x. Second one, if you can enter fractions as fractions, enter them that way. If you can't, use brackets and the divide. So bracket 2370 divide 11 close bracket minus bracket 8 divide 11 close bracket and then x. But if you can do fractions, then do fractions. Just make sure when you attach the variable to the second fraction, you move out of the fraction and then put it beside. So x is beside 8 over 11. It's not on the bottom of the fraction. Then graph that or draw on the Casio. And in our window from plus 10 to minus 10, our standard window, we don't see anything. We have to think about the situation. We're talking about number of tickets to a movie sold, and we know that the total amount adds to 240. So these variables are going to be greater than 10. So we're going to have to make our x and y values higher. So we can try auto, so zoom auto or zoom fit in for the TI. For the Casios, it's zoom, which is F2, and then auto, which I think is F5. So try that and see what it gives you. I get this. What I need to see is where the two lines cross, where they intersect. I can tell that on the right side of the screen, the graphs are closer together than they are on the left side. So that means I want to keep moving to the right. I want to see more to the right. So if I go to my window, left and right is the x. Okay, so x min, well, we're talking about number of tickets sold or number of people at a movie. That can't be a negative. So I'm going to change that to 0. My x max, a plus c adds to 240. So I could try maybe 200. And then my scale, this is just how much it's going to count up by. It doesn't really matter. You can leave that. My y min, you can see it's at 200. I could just change that to 0 because y is also number of tickets. So in this case, I isolated a, which means my y value is number of adult tickets and my x value is number of children's tickets. And then we have a y max of 250. So we'll try that from 0 to 200 on the x and from 0 to 250 on the y. And again, the scale doesn't matter here. Try graphing that. And now I see an intersection point. Now we calculate it. So TI users, second trace, number 5, enter, enter, enter. Casio users, push F5 and then F5 again. And it tells us that the intersection point is at an X value of 90 and a Y value of 150. Part D, how many adults attended the early movie? So we have to figure out which variable is adults. We isolated A for adults, which means in our equation that went in for Y. So the Y value from our point is the number of adults. This is adults, this is children. So 150 adults attended the early movie. People can rent ski and snowboard equipment from 2 places at Winterland Resort. Option 1 charges a one-time $30 fee plus $8 per hour. Option B charges $14 per hour. Define your variables. So option A is a one-time $30 fee plus $8 per hour. Option B charges $14 per hour. What we don't know is the total cost and the number of hours for the rental. So those can be our variables. H equals number of hours and C equals total cost. Create a system of linear equations to model the rental charges. We have to do one for option A. The cost of option A is cost equals. Option A charges a one-time $30 fee plus $8 per hour. One-time fee we should remember from chapter 6-7. If we have an initial fee, that's our y-intercept. And then $8 per hour, that's our slope. So we get 8 times the number of hours plus 30. Equation for option B. Option B charges $14 per hour. There's no initial cost, just $14 per hour. So C equals 14 times H. Part C, solve the linear system graphically. What does the solution represent? So these types of questions, they're a little bit harder to write the equations for, but once you have the equations, they're already written in y equals form, where they already have one variable that's isolated and it's the same variable in each equation. So that's kind of nice. So go to your graphing calculator, go to y equals, clear your previous graphs, enter the new one, 8x plus 30. Enter the second one is 14x. Graph or draw. And I happen to be able to see my window. If I was in standard, if I had been in standard window, I wouldn't have been able to see the intersection point, but I can tell that the graphs are getting closer at the top of the screen than they are at the bottom. So I would want to go window, and I would want to go up, which is my Y max. So I'm just guessing I could try like 50 and see if I can see it there. So enter and then graph. I still don't see it, but I'm getting really close. They're getting quite close together. So I go back to window. I want to go higher, so that's my Y max. Clear that, and I would just try 100. Graph, and there we go. You can see the intersection point. Then find that point, second, trace, number 5, enter, 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 or F5, F5 if you have a Casio. And we get a solution of 570. What does this solution represent? We need to figure out which number is which variable. Our equations have the c isolated. When we put that into the graph, that relates to the y value. So the y value in our point in our solution is the c, and the x value is the h. What does the intersection point mean in terms of option A and option B? Well, notice that the graphs are equal at that point. So what it means is both options cost the same, which is $70, when the rental time is 5 hours. Trisha and Michael share a cell phone plan. Together they made a total of 52 calls last month for a total of 620 minutes. Trisha averaged 15 minutes for each of her calls, while Michael averaged 10 minutes. How many calls did Trisha make last month? Part A, define your variables. So the question at the end, how many calls did Trisha make last month? That gives us a hint to the variables. T equals number of calls by Trisha. And then the other person is Michael, so M equals number of calls by Michael. B, write down a system of equations. It says together they made a total of 52 calls last month. So together means plus the total number of calls made by Trisha and Michael equals 52. They made a total of 52 calls last month for a total of 620 minutes. Trisha averaged 15 minutes for each of her calls, while Michael averaged 10 minutes. So the next equation is going to have to equal the total number of minutes. Trisha's phone calls were averaging 15 minutes, so 15 minutes times the number of calls Trisha made, plus Michael's phone calls averaged 10 minutes, so 10 times the number of calls Michael made equals to the total number of minutes of phone call, which is 620. There's our two equations. Next, solve the system graphically and state what the intersection point represents. We need to isolate one of our variables in both equations. It has to be the same variable for each equation. Doesn't matter which one though, just pick one and isolate. So I am going to isolate the M. Subtract t from both sides. I get M equals 52 minus t. Second equation, 15t plus 10m equals 620. Again, I have to isolate the m so that it's the same as the first one. So subtract 15t from both sides. 15t minus 15t is 0. We get 10m equals 620 minus 15t. I have 10m, I want 1m. I need to divide all of my terms by 10. Divided by 10 is 1. We get m equals 620 divided by 10 is 62, minus 15 divided by 10 is 1.5t. You could actually leave it in this form and just put that into your graph. That would be fine. But this one is pretty easy to simplify, so I simplified it. Go back to y equals, clear the last graphs, and enter your new ones. We have 52 minus x, and then 62 minus 1.5x. Graph. I don't see an intersection point, but I can tell it's going to be to the right because my graph's reading closer on the right side of the screen. So go to Window, left to right, that's your x-axis. So I want to go further right, which is the x max. It's at 10 right now, maybe I'll try 20. I'm just guessing, I don't know. Graph that. I think I can see it, but I want to super make sure, so I'm going to go back to my window and just change it to like 30. Because if your calculator can't see the intersection point and you try to solve for it, it'll often give you an error. Okay, there. I can definitely see it now. Now I solve second trace number 5. Enter, enter, enter. Or Casio's just F5, F5. So our solution is at x equals 20 and y equals 32. Which variable is which number? We isolated the m, which translates to the y in our calculator. So the second value is the m and the first value is the t. State what the intersection point represents. T was number of calls by Trisha, so we would say Trisha made 20 calls and Michael made 32 calls. You have 51 coins that consist of only quarters and dimes. The total amount is $10.05. How many of each coin do you have? So that question, how many of each coin do you have? That tells us what our variables should be. We have quarters and dimes. So D equals number of dimes and Q equals number of quarters. Then we want to write two equations. It tells us we have 51 coins, so the total of the two coins equals 51. D plus Q equals 51. Our second equation, the other piece of information we haven't used, is the total amount is $10.05. So the total dollar amount of the dimes and quarters is $10.05. To figure out the dollar amount of the dimes, each dime is 10 cents, which as a dollar is 0.10. Times that by the number of dimes we have to get the total value of the dimes. Then do the same for quarters and add them together. So plus quarters are 0.25 of a dollar times the number of quarters equals the total dollar value of the coins, $10.05. Now we need to isolate the same variable in each equation. Doesn't matter which variable, just pick one. I'm going to isolate D. So I'm going to subtract Q from both sides in equation 1. Q minus Q is 0. I get D equals 51 minus Q. That's a D, not a 0. In the second equation, I now need to isolate D, because that's what I did in the first equation. So subtract 0.25 Q from both sides. 0.25 Q minus 0.25 Q is 0. I get 0.10 D equals 10.05 minus 0.25 Q. I have 0.1 times D. I want just 1D, so I have to divide all of my terms by 0.10. 0.10 divided by 0.10 is 1, so I get D equals 10.05 divided by 0.10 minus 0.25 over 0.10Q. Again, I don't need to simplify those fractions. If you want to, you can, but I'm just going to leave it like that and put it in my calculator. Go back to where I enter my equations, clear what I have, enter the new ones, 51 minus x, and fraction, if you can enter fractions, do it that way, 10.05 over 0.10 minus another fraction, 0.25 over 0.10, move out of the fraction, then put your x. Graph that. I can't quite see my intersection point, but I know it's to the right. So again, go to your window. Left to right is x-axis. Moving to the right would be x max. It's at 30 right now. I need to go higher than that, so maybe I'll try 50. Then graph. And now I can see the intersection point. Second trace 5, enter, 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 or F5, F5 to find the intersection point. And we get 33 and 18. Which value represents which variable in this question? We isolated D, which means that corresponds to our Y value. So D and then Q. And then the question was, how many of each coin do you have? So there are 33 quarters and 18 dimes. John and Mike sell home theater systems. John earns a base salary of $2,400 a month, plus $100 for each system he sells. Mike earns a base salary of $2,200 a month, plus $120 for each system he sells. How many systems do John and Mike have to sell before they can earn the same amount of money? So how many systems do they have to sell? That's got to be one of our variables. S equals number of systems sold. And then before they earn the same amount of money, so you could put E for earnings or total earnings. The variables that we make in these types of questions have to apply to both people. So both people are selling a certain number of systems, and we're talking about the earnings that they make from selling those systems. So E and S would apply to both people. Then you make an equation for each person. So an equation for John, who makes a base salary of $2,400 per month, plus $100 for each system. So his total earnings E equals his base salary of $2,400 per month plus $100 times the number of systems sold, which is S. Then you write an equation for Mike. Mike's total earnings equal his base salary, which is $2,200 plus $120 for each system Mike sells, so times S. We already have both equations written as E equals, so the E value is isolated, so we can put it right into our graphing calculator. Clear your old equations, enter 2400 plus 100x. And second equation, 2200 plus 120x. Graph that. I don't see anything. Think about our numbers, 100, 120, 2,400, 2,200. Pretty big numbers. So earnings are going to be more than 2,400 and 2,200 for sure. So we could try Zoom Fit or Zoom Auto. And there we go. That showed me. If it didn't, I would just try bigger numbers. I know that my earnings are going to have to be higher than 2,500. So I could just play with my Y max and make sure that is for sure higher than 2,500. We can go to our window and see what it ended up at. So for me, by using the Zoom Fit, it didn't change my X values. Those are the same as the last graph we had. But my Y values go up to over 8,000. So pretty high. Find the intersection point. Second, trace 5. Enter, enter, enter. X is 10 and Y is 3,400. This is the point where the two graphs are the same. So when will they earn the same amount? They will both earn $3,400 when they sell 10 systems each. That brings us to the end of Chapter 8, Lesson 2.